Welcome to the course of structural analysis. So in this lecture, we are going to see the topic that is related to the introduction to proper cantilever beam. Coming to the introduction part, proper cantilever beam. So it is a beam where you are having one support to be a fixed support. That here you can see the A support is a fixed support and another support B support is a simple support or a roller support. For this fixed support, you can have three reactions. One will be a horizontal reaction, another will be a vertical reaction, and another will be a moment at this point. Whereas coming to this roller support, here you are having only a vertical reaction, that is your RB. This is a proper cantilever beam. And this proper cantilever beam, you can say that at fixed end, it is going to resist both deflection and rotation. Whereas coming to this roller support, it is going to resist only deflection, but the rotation is going to occur. Now you can see this is a deflection figure, or you can call it as elastic curve also, this yellow one. At A support, you can write theta A is 0 and delta A is 0, as it is not having any rotation as well as the deflection. Coming to this roller support, you can write theta B not equal to 0 and delta B is equal to 0. So that means at this B support, you are going to have the rotation, but you are not going to have any deflection. Next, coming to the next slide, we'll classify the props. So the props can be classified as two categories. One will be your rigid prop and another will be your elastic prop. So coming to the rigid prop, so there will be no deflection at this prop support when some application of the load is applying. So they do not yield actually. So that means the prop is going to resist the downward deflection due to this applied load. Whereas coming to the elastic props are not rigid props. Therefore, they're something like a flexible props. Therefore, the support is going to get settled or subsidized when some external load is applied. Due to this effect of the settlement, the elasticity of the support has to be considered. So these are the two classifications of the props. Now coming to the next slide, use of a prop in your beam. So while considering this proper cantilever beam, here you are having this prop here at this B support. So due to this prop, while providing this prop or a pinned support, you can call. So it is providing something like a roller support to the free end of the cantilever beam itself. Therefore, by providing this prop, what is going to happen is it is going to improve the rigidity of the beam. And therefore, this proper cantilever is going to provide more stability when compared to your cantilever beam or a simply supported beam. Now coming to the reaction parts, or we can call it as a redundancy also. So at the A support, like a fixed support, you are having a three reactions, that is HA, RA and MA. Whereas at the B support, you are having a only vertical reaction, that is your RB. So total you are having four reactions, HA, RA, MA and RB. And therefore the static equilibrium conditions here are three only, that is sigma Fx0, sigma Fy0 and moment about xy equal to 0. Therefore the degree of indeterminacy we are going to make is number of reactions, unknown reactions minus number of static equilibrium conditions. So that is 1. So the proper cantilever beam is redundant to indeterminacy to 1 degree. So that 1 is your redundant force. So you can call this RB as a redundant reaction. So due to this redundant reaction, it is going to provide more strength and less deflection when we are comparing with the simply supported and cantilever beam. Therefore, it increases the stability of the structure by inducing this redundant reaction. So this is a usage of prop in the proper cantilever beam. So these are the textbooks and references. Thank you.